Hello! In the previous lesson, we introduced the idea of the electric potential, V. The electric potential at a point is the energy per unit charge that we need to invest to bring an electrical charge from infinity to that point. The electric potential is created by a charge or a distribution of charges and is related to the electric field through the expression E is equal to negative the gradient of the potential. Or put another way, the potential difference between 2 points is the negative line integral of the electric field between these 2 points. Just as with the electric field, the electric potential does not depend on the test charge. The potential will be there no matter if we measure it or not. We also found that the electric potential created by a point charge is kq over r. This potential could be positive or negative depending on the sign of the charge. Let's calculate now the electric potential due to a distribution of charges. Consider the discrete distribution of this figure. What should be the potential created at point P? Here, unlike for the electric field, the electric potential is a scalar. This means that it only depends on the distance and not on the direction. This will facilitate the maths involved. We have these 3 charges supposedly addressed, and we want to calculate the potential at P. Because of the superposition principle, I can calculate the electric potential due to each charge individually and then add them up together. I first find the distance from each charge to point P. Finally, I add them together. And this is the electric potential created by this distribution of charges at point P. If I had a continuous distribution of charges, instead of adding, I would have to integrate. But that's something we will do in the next lesson. In the meantime, may science be with you.